Hey, Algebra 3, how y'all doing? Good. I hope you're all doing okay. Feeling good. We're going to talk about 4.5, graphing other trigonometric functions. So we're going to graph other trigonometric functions. What have we talked about so far? We've talked about graphing a sine wave. Oh man, can't write that one on this. We've talked about graphing a sine wave and a cosine wave. Now both of those run parallel to the x-axis, and they run that way, correct? Now think about that for a second. They will run down this way, okay, all the way through. Okay, so everybody's good with that and understands and remembers that, and we can go through that process. We'll review that if we have time in class tomorrow. Now, what is the other function? There's four other functions that we haven't covered yet. We haven't covered the tangent, right? Secant, cosecant, and cotangent, right? Those are the four other ones that we haven't covered. These two we know how to graph. They're pretty straightforward graphs, and so on. Now, when you think about it this way, you think about the arrow. So when you draw the sine wave, what direction are the tips? They're both down, okay? Or they could both be up, but they're both going to be down, all right? So that makes it an even function. An even function. So sine and cosine are even functions because remember, even functions have they're both tails going down or both tails going up, depending on what they are. Now, think about it this way. What would tangent be? So let's think about this. Even. So if you have an even divided by an even, typically you would get an odd. Okay, typically you'll get an odd number. So if you think about it, what will happen with tangent? Tangent is going to look like a little bit different. Okay, so it's going to look like so. And what you're going to see is tangent is going to look like an odd function. Okay, so this is going to be an odd function. So what does that mean? It means a tail up and a tail down. So what we'll do, we'll go like this. Why will it, at that point and at that point, what are those 2 points, and why will it have that little dotted line or an asymptote? Why will it have asymptotes here? Because what do we know about tangent? Looking at your unit circle, how do you get tangent? You put something, you divide something over top of something, right? So what do these become? These are, an asymptote is where that function is undefined, So that function is going to be undefined at negative pi over 2, at pi over 2, and other functions that are undefined would be, the next one would be, this is pi, and then the next one would be pi over 3, right? Or 3 pi over 2. So, because that would be undefined. So every time that function becomes undefined is where you would have an asymptote. So this one's going to go up to here, never touch it, go down to there, and never touch it. So your tangent is going to look like so. Okay? So that's what you're going to be looking to graph your tangent line. All right? So why? It's odd because your tails are what? Up and down. Okay? So any questions on that? Everybody good with that? So you know the behavior goes up and down, right? So think about it this way. It's an odd function, right? It's over the origin, okay? What is the y-intercept? Well, it's going to be 0, 0, right? And what's the minimum? What's the maximum? There's going to be none because it goes all the way up and goes all the way down. There's no breaks to it. All right? Any questions? So if you're looking for the asymptote of this function, you would find it by plugging it into this equation. The equation would be x is equal to 2n plus 1 times 1/2. So in other words, at pi times pi 1/2, because every time that you do this, at pi times 1/2, because every time it goes pi over 2, whenever it goes pi over 2 or a multiple of pi over 2 is when there's an asymptote. Why? because that's when 0 is at the bottom of the fraction. So, any questions on that? Does that make sense to everybody? So if you were to graph an equation, all right, so let's say we're going to graph a tangent equation, all right? Tangent x over 2. Okay? All right, x over 2, right? So first off, what's the period? So remember, when you're graphing these, you just do graphing the same thing. What would the period be? Okay, so it's going to be pi over b. What's the b? The b is what? 1/2, right? Which is really 2 pi, correct? So that's your period, right? Now what? So in other words, it's going to run on your thing. It's going to be pi over 2, negative pi over 2, pi, 3 pi over 2, these are all negative, by the way, 2 pi, negative, right? So, and it would just keep going in that direction, and this would be pi over 2, pi, 3 pi over 2, and 2 pi, okay, and it could keep going up. Now, so your period is from 2 pi, it can be from 2 pi, right? All right, well, okay, I can't do that yet, hold on. So it could be from 2 pi to pi, right? Because your period is over that whole expanse, okay? So let's follow through this and see how you work. Now, let's finish out the rest. So what would the factor be? Where would it go through? Okay, so let's think about this. Where would it go through the the y-axis? What would the initial drawing be of the f of x of a tangent one? It's going to go like this. This is the initial one, and then we would have this for the f of x function. Okay, so what would the g of x function be? The g of x function is you divide it by 2, which means that instead of it being, now watch, I need to use the blue pen. So instead of, because our initial, remember, tangent is a 1 pi interval, 1 pi. So if it becomes 2 pi interval, what are we going to do? We're going to go here and here. Okay, so that's going to be and we're just going to still go through here, right? And it's going to go up, down. And so then what would the next one be? You would have to go 5 pi over 2, 3 pi. So then, okay, and the middle is here. Okay, and it would look like so. Okay, so that's how you would determine your tangents and do it. Okay, so it stretches it 2, so that's why it makes it wider. How do we know it makes it wider? Because it's dividing. If it's up here, so if it was up here, it's going to make it smaller. Okay, it's going to cut it in half. But if it's down here, it makes the period wider. Okay, and that's how you would determine your tangents, and you would graph your tangents. Okay, all right. So think about it this way: if tangent looks like this? What would cotangent look like? Well, it would be just the opposite. It's the negative, right? So if I have a cotangent, it's going to look like this. Okay, it's going to go in the opposite direction. The tails, okay, think about it. Your tails are up and down. Your tails are up and down, but they're in opposite directions. In other words, they're in the inverse direction. So we've got that is the main difference between those two things. In those two functions, they're going through the two different variables. And what else? Where does it become undefined in cotangent? Does it go through 0? It goes through one of these. Because remember, when is cotangent undefined? At Cotangent would be undefined at pi over 2 and this one here. Because it would be opposite of the ones that are defined of a tangent line. All right, so that makes sense to everybody. Is everybody understanding that concept? All right, so when you're looking at it, that's what you'll do, okay? And so what we'll do is let's do another example real quick, okay? Okay, so let's look at a cotangent example. Let me make sure that I'm still recording. Hoping I'm still recording here. Oh man, yeah, we're still recording at 10 minutes. 10 minutes in. All right, so here we go. So if I have g of x equals -2 cotangent x plus pi over 4. Now you kind of have to take into account everything from the first. Okay, where would the shift be? Because remember, if it's inside the parentheses, it's shifting it. What way is it going to shift it? Left to right, right? And so it's positive inside, so it's going to shift it to the left. So your phase shift is h equals -pi over 4. What would your period be? Your period, what's the number in front of x? So your period is going to be what? Pi, right? Oops, pi over 1, right? Pi over 1, right? Okay, and so what's my phase? What's my period? Okay, so I have my period is 5, pi. My phase shift is 2, right? And next is your amplitude. Now, amplitude is a little bit different in this case. In other words, -2, right? So -2 means that if it's cotangent and it's negative, which way are my two tails going to be? Up and this here or this here? What does negative do? It does the opposite, right? So it's going to change. So if cotangent was supposed to be graphed, it would look like this. But because it's -2, it's going to be graphed like that. Perfect. Awesome. And is it going to make it wider or smaller? It's going to make it shorter. It's going to make it smaller, okay? So here we go. So let's watch carefully. So if we're going to graph this, here's what we would do. See this is 0, right? And this is going to be pi over, we gotta label it a little bit different because we're dealing with pi over 4, right? So, well, we don't have to. Pi over 2, pi, 3 pi, pi over 2, 2 pi. And then this is pi over -2, negative pi, -3 pi over 2, pi, or 2 pi, okay? So now, what happens? So where will these go to vertical asymptotes? Where will it go to vertical asymptotes? It would technically be right here, right? Okay, right here, right here, right here, right here. However, we have a phase shift involved. And what is the phase shift? A -pi over 4. So in other words, it's going to be here, right? Technically here, right? Okay. There. Where would the next one be? Right? Sorry. Make sure I got it right here. Yeah, so between these two. We're shifting it. We're shifting it over. So this one shift over. Okay, so I know it's probably not clear. So now you have your thing. So it's going to be right here. And it's noticed that they're a little bit tighter together and there's more of them and they're shorter because why? Because of that phase shift and because of the 2 and etc. So any questions on that? Does that make sense how you would graph that? So now, here's the flip of that. So that's the inverse of tangent. The inverse of sine and cosine is secant and cosecant. So now let's think about that for a second. The opposite of sine and cosine, so remember, what's a sine wave look like? A sine wave is going to look, a sine wave looks like what again? So this is a sine wave. So what happens is, when I want cosecant, and remember, sine and cosine are even. Even if I negate them, are they still even? Yes, they're still even. So that means my tails are going to both be up and both be down on my new graph. So if I want to graph cosecant, what's the maximum of sine? First off, what's the maximum of sine? Is 1. What's the minimum of sine? -1. So when you're graphing the inverse of that, you're going to graph it like so. The minimum and the maximums are infinite. So why? Because the two ends have to do what? Both be up or both be down, because this is even. Does that make sense? So what you're going to do is you're just going to graph a bunch of parabolas, because why? Remember, what happens here? What happens here? What happens here? Your answer is going to go undefined. Why? Because remember your fractions. Remember the fractions that you have at this point. At these points, they go to undefined as opposed to 0, as you would in a regular occasion. So here's what I'm going to have you do. I don't want to take more time because I want you to be able to watch it tonight, and I want you to, and we will go over some problems tomorrow, and then answer questions in the lecture, and then I'll let you get to work. Okay? So this will give you a good start of how to do it, and then we'll go from there. All right? Thanks, guys. Have a good night.